On This Week in Enterprise Tech, the quick brown fox broke Amazon Web Services, AMD brings back the 90s, and your health is going to be connected. Are you ready? Twy on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twy, This Week in Enterprise Tech, episode 229, recorded March 3rd, 2017. Mobile Health Technology Initiatives. This Week in Enterprise Tech is brought to you by GoCD, an on-premise open-source continuous delivery server by ThoughtWorks. GoCD gives you complete control of and visibility into your deployments across multiple teams. Since GoCD is open source, you can download and use it for free. To discover the power of their pipelines, visit gocd.io/twit. Welcome to Twy, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Palliser, the Digital Jesuit, your guide to all things in the enterprise, but I can't guide you by myself. It's an awfully big world. I'm going to need a little help from my friends, starting with Mr. Lou Maresca from Microsoft. He is the youngest member of our co-host trio, and yet he brings so much wisdom, and he's in full-on dad mode. Lou, what's going on with your hair today?
It's raining outside, so I thought, you know what? I'm just not going to even try today. So it's on flat mode.
All right. Okay. I've never seen this side of Lou, and I got to say, it's a little scary. Now, someone who isn't scary at all is my good friend Curtis Franklin over on the right coast of the United States. Curtis, how are things in your part of the world?
Well, we're back to feeling like the late winter rather than full-on summer. It was 90 degrees earlier in the week, but today is beautiful, 70, blue skies. It looks like a great weekend coming up in the swamp.
Indeed. Well, gentlemen, we've got a great show for the Twy Ride today. We got to talk a little bit about Amazon. Amazon did have a little issue this week, and we need to figure out what went wrong. We've also got some news from the autonomous driving field, and we've got a guest, Morgan Reed, is going to be telling you everything you need to know about the Connected Health Initiative. It's going to be a good show. Hang on. But first, we got to start with the blips. Now, yesterday, Amazon released their postmortem on the major disruption that hit Amazon Web Services on Tuesday, and it's an interesting read. Amazon is always thorough with their failure analysis, and this is what we know. On Tuesday at 9:37 a.m. Pacific Standard Time, an S3 team member who was authorized to be working on the system was removing a small cluster of servers from the S3 subsystem in an attempt to troubleshoot the billing system. He followed the playbook, abided by all the security policies, and used the proper storage removal tool to disconnect the subsystem. Unfortunately, he made a typo, and instead of disconnecting the intended small cluster, he DC'd a larger cluster that included several servers in the index and placement subsystems. The index subsystem manages metadata and location information of S3 objects, while the placement subsystem is needed for put requests whenever new storage is required. When those servers were taken offline, each of the subsystems did a full restart, something that hasn't taken place for many years. Taken down together, these systems, well, they took AWS offline. It made it impossible to serve any put, guest, list, or delete requests until 12:26 p.m., almost 3 hours later, when the index system had restarted enough to allow for get, list, and delete requests. At 1:18 p.m., the index subsystem had recovered fully, followed by the placement system at 1:54 p.m., which brought S3 back to full operation. Amazon has learned from this failure and is changing both the playbook and the storage removal tool to prevent incorrect tool parameters from taking so much storage offline as quickly as happened in this incident. They're also poring over their other tools and procedures to make sure a similar series of mistakes can't cause such a cascade failure. Amazon Web Services is a sponsor of the Twit TV network.
AT&T has $40 billion burning a hole in its pocket, but hey, don't worry. It has plans on how to spend it. AT&T says its 2017 CapEx outlay of $22 billion will take its investments over a 2-year period to more than $40 billion, with more than 40% of that going to expand its portfolio of smart, agile, mobile, and integrated business solutions worldwide. According to the operator's official statement, AT&T's investments include strategic investments in the expansion of NetBond, Network on Demand, including FlexWare and SD-WAN. FlexWare, a virtualized network function solution launched late last year, lets customers download routers and firewalls and application accelerators rather than take the traditional route of buying hardware. Now, in addition, AT&T will invest in data-powered analytics and virtualized security capabilities and facilitate the innovation of new security approaches and solutions within its foundry locations. Other areas of investment include IoT, where AT&T will expand its multi-network IoT connectivity and professional services globally.
NASA has released a barrage of software in the recent days. You would think that most of it would be related to, launching things into space. If you dig through numerous categories of software, there you find actually something really interesting and some useful examples. There's actually one for HR. Gives you the ability to have aerospace-grade hiring practices. It's called the Integrated Cognitive Assessment Tool, combining person, system, and mission, which tells you whether someone is capable of performing a certain job, whether it be sales or space. If you're a drone builder, you might be interested in the Consultative Committee for Space Data Systems File Delivery Protocol, which is a standard tool for getting large files to and from moving crafts. And once you've acquired your images successfully, you might want to run them through Pixel Learn, which is based on rules about certain pixels and patterns and program. And the program can automatically find and categorize things like craters and buildings and other things. If the images aren't clear, the video image stabilization and registration can do you some help. And if you want to land your craft successfully, you can always use the Autonomous Precision Landing Navigation System. They also have a cool program called HazPop that lets you browse through a constantly updated world database of natural hazards like fires, storms, and earthquakes, and combine that with data on population to determine the number of affected range of people who could come to aid. Don't be thrown by all the complex and strange names. Go ahead and go check it out at software.nasa.gov for all the details.
Late last century, small chip maker AMD turned the processing world on its head with their K7 line of CPUs, at a time when Intel had grown big and inertia-bound, trickling out processors with only incremental speed increases. The little Sunnyvale, California company released processors that weren't just less expensive, but far more powerful and scalable. They caught Intel resting on its laurels, and the computing world flourished for several years with true competition. Lately, the Intel innovation machine has once again slowed to a trickle, so AMD just did it again. The world's first heard about the new Ryzen architecture engineered by Jim Keller, the same brain behind the Athlon, back at CES in January. But samples have now been in the hands of reviewers, and the verdict? It's good. How good? Well, AMD's top-of-the-line Ryzen 7 1800X processor is faster than Intel's top-of-the-line i7 6900K, and it's less than half the price. There are issues with games that have been optimized for Intel's i7 architecture, but for power users looking to speed video editing or desktop processing intensive tasks, AMD just released the closest thing to a no-brainer that we get in this industry. Even if you don't plan on upgrading your processor, this will make your IT budget very happy, as Intel, with their next-gen chip still months away, has cut prices on their CPUs by as much as $300. With the Ryzen architecture already on its way to the server market, well, long live competition.
Private cloud is very popular, and nobody's doing it. Intel is seeing strong demand for on-premises enterprise cloud, even while conventional server component sales are declining. Now, according to Sandra Rivera, Corporate Vice President and General Manager for the Intel Corp's Network Platforms Group, enterprises are extremely interested in on-premises cloud, but not deploying it because it's too difficult. In an interview with Light Reading's Mitch Wagner, Rivera said, quote, "Everyone is moving to cloud. It's easier to move to the public cloud than to stand up and deploy on-prem cloud," end quote. Intel is working to simplify on-premises cloud deployments by contributing to open source projects such as OpenStack, designed to make standing up clouds easier and building broad ecosystems of providers to assist enterprises. Intel is also developing CPUs, NICs, SSDs, and FPGAs to develop high-performance fabrics to support clouds with integration needed to package and create reference architectures and solution blueprints to eliminate trial and error in development.
Would have thought years ago that the same algorithm that could be used to stream video to your cell phone could unlock the potential of DNA to store data into its 4 base nucleotides. With DNA's resiliency and ability to last hundreds of thousands of years in the right conditions, it makes it a sought-after alternative to the medium for storage. Researchers at Columbia University and the New York Genome Center took a set of files made up of an OS, a French film, an Amazon gift card, and a computer virus and more, compressed them down into a master file, split it into a short binary code string of ones and zeros. Then they used the erasure correcting algorithm called fountain codes to randomly package strings into droplets and map ones and zeros in each droplet to 4 nucleotide bases in DNA, A, G, C, and T. The algorithm deleted letter combinations that could create errors and then added a barcode to each of the droplets for reassembly of the files. It sent the text file for DNA synthesis, and then they were able to recover the files using modern-day DNA sequencing technology and their own software to transform the data back from genetic code to binary, allowing them to basically recover the files with no errors. If you could pack 215 petabytes of data on a single gram of DNA, it might make the big cloud services out there buckle at their knees when they look at their last year's data center costs.
Web services, web feedback services specifically, from Twitter to comment sections, have the potential to be a tremendous resource for companies looking to connect with its users. But that potential is often impossible to realize once the troll flood comes. From the disgruntled employee who posts the occasional bitter story to drive-by professional haters, most comment sections quickly become a cesspool of hurtful, hateful, and arguably ignorant musings. But a Norwegian public broadcaster may have just found a way to turn the tide. Last month, NRK Beta, a tech blog that is part of the Norwegian public broadcasting system, added a feature to its comment section that requires users to answer 3 basic multiple-choice questions about the story connected to that particular comment thread. Since the activation of the feature, the tone of conversation in the forum has become markedly more civil, with very few users shotgunning the same incendiary comments across multiple pages. It's a remarkably simple and non-time-consuming verification that increases the likelihood that the commenter will at least have a cursory understanding of the story before posting. This won't stop dedicated trolls, nor will it deter relevant critical commentary, but the idea of asking users to have a little skin in the game shows promise as a way to drain the swamp of internet feedback. That does it for our blips. Next up, the bites. Specifically, we need to talk a little bit about autonomous vehicles. They are on their way, and they do mean something important for the enterprise. But before we get to that, I need to talk to some of you, specifically to the developers out there. Hey, look, I understand your job is very, very difficult. You get very little thanks, very little praise when things go right, and you get all the blame when things go wrong. I mean, look, we could just look at some recent examples to see where developers get the shaft, where they always seem to be the bad guy. Well, lucky for you, I've got a way for you to look good and to decrease the amount of work you need to make that happen. Specifically, I'm talking about GoCD. GoCD is an on-premise, open-source, continuous delivery server created by ThoughtWorks that can soothe your deployment headaches. GoCD gives you the ability to model complex workflows across multiple teams with comprehensive pipeline modeling, giving you the ability to see exactly what's happening along every step of your deployment. With GoCD, you can model both parallel and sequential execution that lets you configure dependencies for fast feedback and on-demand deployment. GoCD's fan-in, fan-out dependency management always does the right thing, saving you resources and avoiding spurious builds. What does all of this mean? Well, in a word, visibility. Their value stream map lets you track a change from commit to deploy at a glance. You get a complete picture of deployments across your organization so that you can be agile in your response and see issues before they become problems. GoCD also offers complete customization for your software's individual needs. It can perform tests written in most languages or frameworks with detailed logging, letting you know exactly which change set and on which platform a test started breaking. You can compare content across any 2 arbitrary builds, making it invaluable when you troubleshoot a broken pipeline or look at best practices and best builds or best forks. GoCD is fantastically flexible. It supports audible deployment. It lets you delegate the configuration of pipelines to users without full-blown admin privileges. It has extension points that let you connect any number of ready plugins or design plugins that you write yourself. All of this adds up to you saying goodbye to a deployment panic and hello to consistent, predictable deliveries. In other words, GoCD turns you into a superhero. Here's what we want you to do. We want you to say goodbye to deployment panic and hello to consistent, predictable deliveries. To learn more about GoCD and for a free download to try it for yourself, visit gocd.io/twit. That's gocd.io/twit. Commercial supported enterprise add-ons, including disaster recovery, are also available, and we thank GoCD for their support of This Week in Enterprise Tech. Gentlemen, we got a little something brewing, and you know what? We got to get the enterprise in front of it. Specifically, I'm talking about autonomous vehicles. Now, I know we've covered it to death across the Twit TV network, and yes, there's a lot of promise, and yes, there's a lot of very interesting technology, but we haven't really had a chance to sit down between ourselves and look at some of the new realities, the new technologies that are emerging, and the new strategies that enterprises and large companies are putting into place to take advantage of this revolution. Could 2018 be the year where the autonomous car becomes the normal thing? Well, let's take a look. Now, there's been some interesting news that's been trickling out about this field in the past 2 weeks. Uber has announced that it's applying for an operation permit in California after a very well-publicized temper tantrum against the city of San Francisco and the state of California that saw Uber angrily announce that they're going to test in Arizona instead of the Golden State. Autonomous driving was a talking point at both the Game Developers Conference here in San Francisco and at the Mobile World Congress in Barcelona. A Tesla on autopilot yesterday crashed into a poorly designed barrier on a highway near Dallas, Texas, and 2 weeks ago, Reuters reported that GM is planning for a 2018 deployment of autonomous Chevy Bolts through a partnership with Lyft and their newly purchased Sidecar, which is a failed startup that GM snatched up. Gentlemen, let's start with this. Let's take it at face value. Looking at this, it's easy to see that, yeah, there's a lot of money in autonomous cars, and we know from the stories that we've gotten back from, say, Intel's investment in the technology that there's going to be a lot of data, a lot of big data points that will be coming back from these cars' sensors. But where do you think the enterprise should be positioned? Lou, for example, let me start with you. You represent a consumer/enterprise business company. Where do you see the promise of autonomous vehicles in turning Microsoft from that sort of big conglomeration of enterprise-focused technologies into one that sees the interface as more holistic from home to office?
That's interesting. I think, it's funny because on the way to work, you can actually take this thing called the connector. And when you get on the connector, it's like you're walking into a mobile office. And, it's really kind of, an hour a day I can get back to basically do my work by just having the ability to have somebody drive me there. And normally people can't afford to do that themselves, and normally people don't want to take public transportation all the time. So this might be a good alternative for them to own their own vehicle and to also be able to get driven somewhere. And I think that's one thing. That's one of the easiest things to come up with. But this also goes with going across the industry from any type of I talked about in my predictions around the trucking industry kind of stepping into that zone of really changing how things are delivered across the country and delivered across even several other continents is when you allow trucks, especially that are going to be delivering goods internationally or subnationally, that makes it an interesting thing because they can continue to go and then make those trucks economic and then you have this delivery system for businesses to be able to do and not have to pay the high prices and the high insurance prices of the trucking industry, and so that it kind of changes the scope and the shape of that industry as going forward. Most large industries they get caught up in the cost cutting of manufacturing and development, and they don't get caught up. They don't get into the innovation side of things, and I think that's where this might help, especially kind of get rid of that cost cutting side of things.
Actually, very, very good point. I think that's one of the things that we, on Twite, we should focus on. It's so easy to look at this technology and think, okay, cost-cutting, getting rid of drivers, look at the technology in how it will apply to my business model. Not enough is being paid to, well, what does this mean 10 years down the road? If we start moving to an autonomous economy where our vehicles can drive themselves, especially cargo vehicles, well, that means that all new industries open up. That means all new opportunities open up. And it's the people who figure that out that are going to have the advantage in the next part of the cycle. We've got a couple of good comments in the chat room. We've got JJ the 4884 wondering if there are any dumb cars anymore. And this is one of the things that I think people who are versed on the subject have been trying to remind people, which is if you drive a car that was made after 2005, you're driving a smart vehicle. It's using smart brakes. It's using some sort of computer to control the engine. Even the steering is controlled by, it could be controlled via the computer. So the only thing is turning that on, allowing it to have the smarts and the sensors to know what is around it. So, the transition technology-wise isn't actually going to be that great. The transition, what it means for the business model, might be. Curtis, let me bring you into this. I love what Lou is saying about not just looking at cost cutting, but looking at innovation. Where do you think the innovation is going to be? We are going to be getting terabytes and terabytes of data points from all of these drivers and all of these vehicles. I mean, can you stare into your crystal ball and tell us what kind of new industries this might spawn? I know this is sort of like the $1 trillion question, but I'm going to give it to you because I'm the host of the show and I get to throw it to the people who are swearing at me in the monitor.
Well, it's interesting. For a lot of reasons, we tend to focus on things like the autonomous passenger vehicles, and there's nothing wrong with that. I think that those will come along, and I think those will offer some opportunities. But where I see the true opportunities for the enterprise are in commercial vehicles. Let me give you a couple of examples. One is in things like agriculture, where there are already fully autonomous vehicles. Massey Ferguson, for example. If you write them a great whopping big check, will happily sell you a very large tractor that can be programmed to follow GPS coordinates and plow your fields for you, and do so with incredibly straight lines, with tremendous precision, and no human being aboard, which means it can do it at night, do it 24 hours. So that's one example. Another is one, and I've been looking on the internet while you and Lou have been talking. I saw a story very recently about a system that's coming online that will allow trucks, 18-wheelers in the U.S. to convoy together. Now, this has already been shown and demonstrated in Europe, but imagine a set of 2, 3, 4, 5, 6 18-wheelers where only the front truck has to have a driver that is fully in control of the vehicle. In the rest of them, they have drivers, but they're completely hands and feet off. What's the point? They can follow one another much closer, basically ride in one another's slipstreams. And I've seen estimates that this can save something like 10 to 12% of the fuel costs of each of these trucks as they go across the country. Given the amount of fuel that's used in trucks in the U.S., this has potentially huge savings. So I think these commercial applications are the sort of place where we're going to see the initial deployments for a couple of reasons. The money that can come back, and to be honest, the simplicity of the environment. When you start talking about passenger vehicles, you put those vehicles inside cities. And in conversations that I've had with engineers at Ford and General Motors, they talk about the complexity of a city street in terms of an environment in which an autonomous vehicle can work. Compared to that, the interstate is a piece of cake. So those sorts of places, the interstates, farm fields, I think those are the places to look for the first large-scale autonomous vehicle deployments.
Right. Actually, I know exactly where this is. I took this road yesterday on the way back from Moscone Center. This is down near Howard. But by the way, that's in San Francisco. I think you're absolutely right. There are a few types of applications that are far better fits, more natural fits for this type of technology. We had HiWeb in the chat room saying, well, I mean, farming equipment, combines, yeah, that should all be automated. We have also got JJ to the 4884 saying, yeah, you know what? And one of the other industries is when you design these devices, this technology, the software that runs it, you're going to need to make sure that it can not be owned by an external attack. When we were at CES, I did stop by the Ford booth, and I had a really good talk with the man who is in charge of their autonomous vehicle program. And off camera, he made a very interesting comment. He said, look, we see what's happening in the Silicon Valley, and we're excited. We see this technology. We see how it's being developed. We know that there's promise there, but I don't think a lot of these Silicon Valley companies realize exactly how difficult it is to implement great new technology into vehicles that actually have to exist in the real world, that deal with real people, that can kill real people. This is not a beta of a new email app. This is something that is a ton, 2 tons of steel rolling down a freeway that could really cause damage. And I think, you've got companies like Ford and like GM and like Toyota who have a much, even though we see them as slow to adopt this technology, they have a much more realistic view of exactly what it's going to take to make this practical. All right, let's push forward a little bit in the story. Now, we know that this partnership with GM and Lyft happens because GM owns $500 million of Lyft. That's what they invested in that company. And we also know that they're probably going to be doing most of their testing in California, specifically in San Francisco, a little bit in Los Angeles, and then they're going to be scattered across Lyft locations across the United States just to check. They probably will still be having a Lyft driver inside the car, but they're going to be using this test, this rollout, as a way to look at real-world deployment strategies. For example, I did mention earlier on in the Byte that yesterday there was a crash of a Tesla near Dallas, Texas, on the highway because of a really, really poorly designed barrier. It just kind of popped out into the lane, no cones, no nothing. The Tesla didn't notice it until it was too late. The avoidance system kicked in, but there was a car over to the right, and so it basically hit the barrier, deployed the airbags, and then sort of ground to a halt. We're going to see much more of those kinds of incidents. There's going to be more and more of these things that were not planned for, that were not programmed for. But, and Lou, I want to throw it back to you. When do we see the completion of the looping cycle? Because the way that this typically works is we will have a technology that is deployed, then things will happen with that technology, and then you change both the technology and the environment in which the technology is deployed. So at some point, roads start getting designed so that autonomous cars will navigate them better. When does that happen?
It's always innovation first, and then innovation kind of pushes things forward. I think that's kind of the key. And when does it happen? It happens a lot faster nowadays. I mean, you'll start to see, innovation come along that will push not only governments but also industries forward to support that type of technology. And I think, I think you'll start to see more and more. You're already starting to see, small towns produce these magnetic strips in the streets and to be able to support these types of vehicles. And I think that will happen sooner than later, and especially in large cities where people like to get in traffic jams. And I think, this will also help, like Curtis was saying, from a perspective from, transcontinental kind of travel. To have to support that, you have to have some kind of infrastructure in there. There's all these different technologies that people are different industries are using for autonomous vehicles today. There's not any one standard, which is unfortunate yet, that they've kind of zoned in upon. And I think that will be one problem that will prevent the industry from developing infrastructure to support the technology, because there's not one technology that they need to support. And so once they hone in on that one standard, whatever that might be, whatever combination of technology it might be, then then it'll start pushing the infrastructure to start to support it, especially as more people adapt it. So as more consumers and commercial adaptation comes through, you'll start to see the industry move through and kind of adapt to it. But it's always after the fact.
Yeah, and unfortunately, that's the case. When this technology does make its big emergence, and it's not going to be a day that suddenly we say, okay, we're all autonomous now. It's going to be a slow rollout where more and more companies start competing in this space. 1 or 2 companies will get the formula right, will become the popular choice. Everyone's going to model after the version of the technology that they've used, and then we will start to see the emergence. Now, when I say 2018, of course, the story said 2018 could be the year of the autonomous car. It means that that's the year that we're going to start seeing deployment. Ford is already saying, look, we know we're going to be ready in 2020. So by 2020, you're at least going to have 2 major car manufacturers who are on the autonomous boat. I think that makes a difference. Curtis, we got to move on, but let's just do this really fun part. I'm actually looking forward to this being tested in San Francisco. Would you take an autonomous taxi? Would you take a Lyft with no driver? You just jump in the back seat.
Oh, sure. And I'll be honest, I am looking forward to the day when we do have autonomous cars. I enjoy driving under some circumstances, but there are a lot of occasions when I just want to get from one place to another. And if an autonomous system can do it safely, cleanly, efficiently, and most important economically, I'm all for it. Do I anticipate a lot of societal disruption? Yeah. But societal disruption seems to be the order of the day rather than an exception these days. So let's bring it on, embrace it, and see where it takes us.
Yeah, I'm sort of the same way. I also think that once you start seeing these types of vehicles actually being used for Lyft and Uber and any drive or car sharing services, people will say, okay, this was nice. I didn't get into an accident. This is the next car I will buy. I think that's really going to be the impetus. It's going to be you ride in one and say, this wasn't the life-destroying experience I thought it was going to be, so maybe now I need to think about making this for my next car purchase. Lou, what about you? You've got a family. You've got kids you have to worry about. Would you trust them to the autonomous car? Would you put your kids, I know they're really small right now, but would you put your kids into a car and say, hey, car, take them to school?
Honestly, I wouldn't. I actually fear getting into one in a Tesla, which I've tried before, and trying it, just letting go of the wheel. I have a sense of fear when that happens. I don't know why. And so I at this point, I guess I won't. I wouldn't.
It's okay, Lou. We have medication for that. Gentlemen, okay, this has been a lot of fun, but you know what? It's that time of the show where I get to introduce our guest, where we get to bring someone in who can drop some knowledge on the Twilight Right. So I welcome to This Week in Enterprise Tech, Mr. Morgan Reed. He is the Executive Director for Connected Health Initiative. Morgan, thank you very much for coming on to the show.
Good to be here.
Now, could you please tell us a little bit about CHI, the Connected Health Initiative? Exactly what is it?
Sure. So CHI is an offshoot of the work we've been doing at the App Association, as you can see in the logo behind us. What we realized in talking to tens of thousands of developers around the country and engaging with physicians, healthcare systems, and insurers is we realized that the standard discussion of, well, we're going to disrupt things and change the world through disruption alone really missed the boat when it came to dealing with who the customer is in the normal healthcare system. And so we took a step back and looked at what we were facing and realized that there are really three elements that technologists need to start embracing, understanding, and respecting when it came to how to bring all these amazing technologies in our lives to improve our health. And it was simply, we need to find a way to make sure that the products that we're developing, these disruptive technologies, are secure, that we are taking privacy into consideration, that we consider whether or not they work. And then finally, how do they fit into a system where ultimately someone has to get paid? For example, last year alone, the U.S. government spent nearly $3 trillion on healthcare. America spent $3 trillion on healthcare. Of that, nearly $1 million went through the Medicare and Medicaid systems in the United States. But here's something your audience might not know. The total amount reimbursed for telemedicine, that is real-time voice and video with a doctor, $12 million. So out of $1 trillion, we only did $12 million in reimbursable telemedicine. And so that tells me, since the technology that we're talking on right now has some of the capability you expect for a telemedicine consult with your doctor, that we've got deeper problems. And so we've been looking at those, pulling together about 150 major stakeholders, from physicians to academic medical centers to technologists, insurers, and even nurses, to work together to figure out, how do we meet these three-legged stool of goal of privacy and security, reimbursable, and then finally effectiveness, to create a room for innovative products to have success. And I thought it was interesting, as we talked, you gentlemen were talking earlier about the autonomous car. Many of those same problems come to the fore when you're talking about innovative healthcare products. Sure, we all have a Microsoft Band, Apple Watch, Fitbit, but how do we get that data to the doctor? And think of it this way: how does the doctor know it's accurate? You know, if you've thrown your Fitbit in the dryer, what happens to the score that your doctor sees? And now imagine that maybe that has a sensor that monitors your blood pressure or your heart rate. How do we take that information in? How do we deal with the terabytes of data that we're going to be absorbing on the healthcare front and make it actionable and useful by the doctors that treat us? So, a long-winded version, we're trying to tie technology and healthcare together to solve the problem that we all have.
I'm glad that you brought that up, the idea of disruption, because we love disruption. I mean, that's been the buzzword for the last decade. Anytime you can disrupt an industry, obviously there's potential profit, and obviously there's potential to move us into something that we hadn't imagined before. And yes, it's very much like the autonomous car, the autonomous vehicle industry. But like the autonomous vehicle industry, there's a lot of unknowns which make this different than, say, releasing a new app for entertainment or a new piece of technology for a connected house. In that, look, you're dealing with sensitive data. You're dealing with sensitive data that doesn't just have personal security ramifications, but has legal ramifications. And that changes how you disrupt. You can't just throw things out in the open, make a bunch of mistakes, and then fix them, because your company will go bankrupt by then. So,
well, actually, we call it the killing grandma problem. That if you want to think of it this way, we all love technology. We're willing to iterate. You come out with a version, you have an oops, you change it. But think of it this way. If you're developing some clinical decision support software, meaning software that supports a physician making a decision about what treatment to give you, well, if you had a miscalculation, or you carried the zero, or you moved a decimal place, and a patient is given 12 micrograms instead of 12 picograms, that's a medical situation that moves from an oops to a death. And so when you're looking at these things, when physicians say, hey, we love all your talk about disruption, but how do we know that it's not going to hurt someone? That is something we all in the industry have to take seriously. And I think that's where we have to look at the academic medical centers and technologists to really move forward. But here's the promise of it, and I don't want to lose track of that. If you're a physician and you're an amazing physician and you really know your stuff, you'll see in your lifetime maybe 10,000, maybe 15,000 patients. And let's use Mrs. Jones. Mrs. Jones has a couple of diseases, some comorbidity, and some interesting genetic traits. Maybe in your entire time of practicing medicine, you'll see 100 people that are similar to Mrs. Jones. Now imagine that I can use big data and I can combine that, and I can give that physician the ability to look at what treatment works not on 100 patients, but on 1 million patients, 10 million patients who have similar genetic traits, similar comorbidity, similar age, similar characteristics, and say, oh, well, it turns out this treatment works better than that. This surgery isn't necessary. This kind of patient engagement tends to be more effective. So the promise of it is the kind of thing that means we reduce unnecessary surgeries, we reduce the wrong treatment of medicine, and we're handing that kind of information and insight into a physician who's doing their best with the knowledge that they have and replacing it with the knowledge of all the physicians have gained throughout the country.
Okay, so when looking at those types of technologies, the technologies that reduce the number of unnecessary surgeries, that give physicians more information and more accurate information about their patients, what are some of the technologies that you've seen that you think are most promising?
Well, on the clinical decision support, there's a lot going on. IBM has been pushing Watson. Apple, of course, is on the fringes of it with both HealthKit and ResearchKit. But I'll bring it down to kind of a small scale reality of how data and mobile health technology is having an impact. There's a company called Airstrip that already has a system where they're tying in real-time or near real-time data from ambulances that's sent over to, hold on.
The motion sensing
the
tyranny.
motion sensor light. We're green here. Taking that data from an ambulance, rushing you to the hospital, sending real-time telemetry on an iPad that you can look at, and the doctor can say, oh, this patient needs this size of catheter or this size of stent. And they can make a difference in the operating theater so that when you're wheeled in, the operating theater has the right size, the right technology, and it means the difference between the difference in your recovery time and sometimes the difference between life and death. So the ability to draw data, huge data sets down live in an ambulance and send it in to the hospital is enormously meaningful. You've got simple technologies. A study in Detroit looked at children who had chronic asthma, and they realized that with some gamification and with a mobile app that engaged with the child, they could make the difference about an 87% reduction in these children showing up for acute treatment of their asthma. In other words, the kid has had an asthma attack, has to go to the emergency room. Turns out those kids forgot to take their puff, forgot to take their pill. The signs were there that they could have gotten ahead of it and didn't. Now, you hand a smartphone, you give them good technology, a great user interface, some tie-in to the care team, and all of a sudden, that child who forgets to take his puff every day now gets a star for it, gets a reward, has a doctor that's kind of looking over their shoulder and saying, hey, Timmy, you need to take your puff. We reduce that time that they spend in the emergency room. We reduce that stress on the family. So something as small as remembering to take your puff to as large as making sure the heart stent matches your body while you're being wheeled into the hospital, that's where we're seeing telemedicine and where we're seeing remote patient monitoring. The final category is something that we all know on this, which is all of those sensors, the speed and quality of the sensors on mobile devices, from the Fitbit that we had to where we know it's going to be. Under Armour's CEO said he wanted to have 80% of their clothing wired by 2030, I believe. So imagine that every piece of clothing you have now has high quality, high value sensors on it. How do we take advantage of that, hand it to the physician in a useful way, and make something out of it? It's a company that has a deal with Blue Cross Blue Shield called ACES. They set up some technology to monitor about 100 different fitness wearable remote patient monitoring devices, tie it in, bring it to the physician in a screen that shows green, yellow, red. And so the physician can, at a glance, look at his total, what's called population health, and make a determination. We need to call her in for a consult. He looks good. He's at yellow. Let's make a change. Those are the kinds of technologies that we're seeing. But we've got to make sure that we are listening to the patients as we move forward on that kind of disruption.
A lot of the technology that you mentioned that is most ready to go is the back end that, say, informs the emergency medical tech. And that absolutely makes sense. You should have a device that can give you all the pertinent information about a patient. And I don't mean just hand over all the files. I mean, say, look, this is the data that we've compiled. It's gone through IBM's Watson. Yeah, make it meaningful. What can I do in the next 30 seconds that will improve this patient's percentage of surviving? I mean, that's a no-brainer. But that last category of technology that you talked about, that's the one that gets me really both interested and worried, because you mentioned at the beginning of your talk that you need to make sure that that data is reliable. And right now, they're consumer devices. They're not enterprise grade. There's no way to make sure that that Fitbit is giving you the right pulse rate. There's no way to make sure that that exercise band is giving you the right blood ox. So you can't really depend on that. It could be as simple as a software glitch or a hardware problem. So if any of that equipment, if any of those devices might be giving you erroneous data points, do you, in a health compliance system, kind of just need to disregard that?
Yeah, that's the big thing that we're working on. So there are a couple of realities to that question. First, I know this sounds hard to believe, but the quality of sensors that you're currently seeing in a lot of mobile devices are actually better than the grade of sensor that is in medical grade FDA-approved devices. Now, what's interesting is the software is not as good, but the sensor itself is. And that has to do with the reality that everyone who watches this show knows. We all know that technology gets better, faster, cheaper at basically the speed of Moore's observation, although we call it Moore's law. So when you think about that quality of the sensor on the Fitbit now versus the quality of the sensor that will be there in the future, the sensor is going to be the part that's going to be the least questionable. The software that runs it, the analysis that's done, that's where the questions are going to lie. I think the second part is all of us here who do enterprise-grade equipment understand how to build systems that are tolerant to erroneous data. And I think that that's right now what our industry is looking at. How do we keep the physician or the care team or the nurse practitioner as the learned intermediary while we give them insight into the data? And the problem is, as we all know, a raw data dump is useless. So the real question is, how do we build software and engines that can take the data in from multiple sensors, look at it, analyze what's likely going on, throw out the noise, and provide the signal? But here's the part that makes this challenge very interesting. When it comes to health, sometimes someone who's sick actually has data that looks like noise, but it is in fact the key signal that you need to receive. So this is why I think so many health startups have had a hard time succeeding. Our Silicon Valley mentality is, let's just give it a try, throw it out there, iterate fast, and make improvements on the change. What is it? Move fast and break things. The problem is, at the other end of it is a physician who has to make a decision, and that is, do I accept your technology into my medical practice or take your data into my medical practice when it might not be right? So that's why we're really focused on that effectiveness part. And so if you start on the low-hanging fruit, how do I do patient engagement better? How do I pull in data from a Fitbit and provide it to a physician, not as a key determining factor, not, cut here, but rather, hey, here's a data point that might inform you. And it looks to be signal. It doesn't look to be noise, but maybe this is something that raises your attention. Why don't you give the patient a call? Why don't you reach out? And so you're seeing a lot of those kinds of assistive information being developed right now. But full-fledged by this, believe in what you're getting from a consumer-grade device, I think you're exactly right. We're still a ways away from making that a medical-grade informatics tool. So let's start with what we can do, get that medical-grade information, get a better user interface on it, use big data to save lives, and then incorporate the consumer-grade as we go. Your earlier discussion about do we really see autonomous vehicles more in the enterprise space, in that space, and then moving over to consumer? There's some analog there on how we're going to do it in the medical space as well.
Right. And I think you're right on there, where the consumer-grade devices can still provide interesting data points, but it's more as an entree to a conversation with an actual trained professional physician who can say, okay, well, this data set doesn't make much sense. I think that's erroneous. This is probably what we should be looking at, and here are a few of the things that I think you can use to improve your personal health. To your point about the data dumps, I think the IT people in our audience really understand this. A raw data dump, when you're in a state of emergency, when you only have a few minutes, few moments to actually look over the data dump, a raw data dump is worse than useless. It's actually harmful because I don't know if it's human nature, but we tend to gravitate towards the extremes of the data dump. When we look at all the data, we'll look at the high points and the low points, and we tend to focus on that. Even though we know we shouldn't, that's the thing that we just kind of gravitate towards. And especially if you're dealing with health, that could be 100% the wrong thing to do. That could be the fatal mistake.
But the upside is also really important. If you look at the state of Mississippi, this may be a surprise to your audience, the state of Mississippi is actually on the cutting edge on a lot of telemedicine and remote patient monitoring. And in large part, that has to do with the dire economic straits of the state and of some of their populace. They've figured out that they had people who were 2+ hours away from a primary care physician, but those people desperately needed care, type 2 diabetes or other problems, and yet they lacked a car or another way to get to the care that they needed. So the state of Mississippi started investing through the University of Mississippi Medical Center, started investing in the technology and the capability to do both remote patient monitoring, but a lot of patient engagement. And what you find is culturally, we have been trained to essentially ignore our health until we go to a doctor. The doctor tells us what to do, and then we go back to ignoring our health. So the question is, once you've identified a problem, how do you keep a person engaged in their health? You often hear people say, well, people want to be informed about their disease. I think the reality is people want to be engaged in their continuous health, not their continuous disease. So finding those structures, whether it's a video chat with a physician or a nurse practitioner, whether it's a device on your wrist that buzzes, those are the kinds of things we need. But I want to step back for a moment and identify the reality. This thing we're talking about isn't a pipe dream. It's an absolute economic necessity for America. By 2050, you'll have 1/3 of the United States population over the age of 65. And here's the other key thing that goes along with that. In your last 2 years of life, the average person uses up 33% of their lifetime healthcare spend. So if you do those two numbers together, and realize that the United States is already spending roughly 20% of its GDP on health, technology isn't a nice to have, it's a must have to prevent our country and a large chunk of our population from just going bankrupt.
Right.
So when we're looking at these, we're looking at how do we serve that. Earlier, Lou said something about long term. We have to get ahead of this because the long-term consequences of not are an absolute disaster from an economics perspective. So I'm very hopeful that we can solve the problems now, work with regulators, work with physicians, work with academics to try to build a model that's sustainable going forward in the future. And if I'm wrong and we don't do it right, well, I don't know what kind of healthcare we'll end up with by 2050.
I like the hopefulness. However, there's another part to this, which is when you talk about the promise, ultimately, it does all still go through the FDA. I mean, when you talk about acceptance by doctors, by physicians, it needs to be approved. Does the FDA actually have the resources and the personnel to make informed decisions about which technologies to approve and which technologies not to? I mean, is that one of the issues that CHI handles?
Well, yes, we work actually very closely on that issue. And for once, I get to tell good news about a government regulator. You know, that happens once every blue moon. The Food and Drug Administration did something very interesting back in 2013. There was one gentleman in particular who helped spearhead it, but they came out with a document that's called the Mobile Medical Application Guidance. And it's the September 2013 document. And what the FDA did was, instead of itemizing thou shalt nots, they actually came up with a risk framework. And they said certain categories of mobile medical applications are never really going to be regulated. We're not going to look at them. We don't care. We don't care about your BMI calculator. It's not interesting to us. You know, go forth, promulgate, build your app. Then there's another category of applications that they said are absolutely going to need to be regulated, ones that have immediate clinical impact on a patient or the way that the physician practices medicine. And that top category, high-risk apps, those ones are absolutely regulated. You have to file a 510K, go through all that process. So we've got that top category and we've got the bottom. And then they did something very unusual for a regulator. They set a middle category and they said, these are areas that we think that any risk that's going to come about, we'll have enough time to get in front of. So we're going to treat them as things that we are not regulating, but we're not going to say we're not going to ignore them. And they use a term that's called regulatory discretion. So they're essentially looking at a category of mobile medical applications and uses and saying, we think if a harm shows up, we'll be able to get in front of it and put in either oversight or regulate the specific product or the category of product before anybody's really harmed. And that idea of a government agency that regulates these products saying, hey, we know we don't know everything, and therefore we're going to let some innovation happen, I think was really remarkable. And to their credit, they've kind of stuck with it. So right now, lots of mobile medical applications, lots of health and wellness applications don't require an FDA 510K. Now, the flip side of that conversation is the FDA's done a good thing, but sometimes the lawyers haven't. And so oftentimes companies who are working in this space, they don't have to go before the FDA, but if they want to sell products, they need to get an FDA clearance. So the poor folks at the FDA have actually had people come in and say, well, I need to go through a 510K. That's the clearance at the FDA. FDA says, you don't need one for your product. And they say, yes, but we want one anyway so that we can make a sale. So it's 2 steps forward, 1 step back. We still need to deal with the lawyers. But right now, the FDA is actually a good place.
All right. I want to bring in my co-host here because I can see them in my preview monitor and they're chomping at the bit. Curtis, you had a couple of questions about HIPAA compliance. I mean, of course, we have to talk about that because every time we have Chibert on, he bangs the HIPAA drum. What are your concerns here?
Well, I have a number, and some of them are directly HIPAA related, which means, you know, as you know, it gets into issues about the safety and privacy of the data involved. Other comes from a lot of discussions I've had with physicians, less out of HIPAA and more out of the Affordable Care Act, with things like meaningful use and diagnostic codes. Coding data is one of the things that has become one of the banes of many physicians' existences. I don't think I have talked to a physician in the last 5 years who has had good things to say about it. When you're talking about adding more data to what's available, as you talk to physicians, do you get a sense of whether they are looking forward to using this to simplify the task of coding data? Are they dreading this adding to their burden, or is it more complicated? Is it a generational thing where doctors who are recently out of med school are looking forward to it, and those who are, let's generously say, later in their careers are a little bit more reluctant to embrace this for fear that it's just going to add to the burden of paperwork they have to do?
Well, Curtis, that's not only a great question, but one that I personally spend a lot of time on. It turns out that the process by which the codes are developed is monumental, and it's monumental for good reason. But I've been fortunate enough to be working with the CPT working group that is coming up with the codes for remote patient monitoring and telemedicine. And I can tell you that we've had very interesting discussions with physicians, specialty practices, and the rest on simple things like, what is the definition of asynchronous? Right now, when a physician reviews your data, that's handled under one code. But what if that data is something that comes in over time and he looks at it, maybe checks it's a red, green, yellow, and he only looks at it for a minute? Well, if he looks at it for a minute every day, how does he code that? Because he's not spending 10 or 20 minutes reviewing your x-ray that he has a code for, but there isn't a code for the kind of process that he might do where he's looking at a dashboard and looking forward it. These are the exact questions that we're working on, and I have to give some credit to the folks at the American Medical Association and others who are embracing these questions on behalf of physicians and starting to look for solutions. Coding has been one of the most fascinating and humbling experiences I have ever had as a technologist. You're exactly right that it is both a burden, but also the key for a physician in order to earn a living and keep his staff. So how we do it is going to be critical. And there's elements that you haven't even thought of, or I hadn't thought of, which was, well, what about things like practice expense, right? If I do something over this webcam or I do something by monitoring, I'm not using a tongue depressor. I'm not keeping the lights on in my practice. And yet, when I have somebody come in, I'm able to bill for the experience that you have at my physician's office. Well, how do I replicate that when the costs are different if I'm doing it online? And yet, in the case of most physicians, I still need a bricks and mortar place to go to do a laying on of hands. Because while I might monitor you every day of the week, 365 days a year, I probably still need you to come in, talk to me, do some other tests 6 or 7 times. So how do we balance that code? How do we respect the fact that the physician has to have a physical place to do his practice, and yet some of the costs are going to be different? So coding is a great question. If we want to break, I can go back to HIPAA.
Let me ask you a quick question, a little bit deeper on the coding, because what we're talking about for maximum value on a lot of this data, we're looking at getting a long-term stream of data and being able to compare readings over an extended period of time to get a comprehensive view of health conditions.
Longitudinal data. That's right.
One of the things that most coding is really bad at is dealing with chronic conditions. And I say this as someone who has some experience in chronic conditions. When you go into a doctor's office, if it's, gee, you're doing great, keep doing what you're doing, there's not a great code for that. The coding tends to want for there to be, as part of meaningful use, a new encounter and a new diagnostic code for every encounter. Is that the kind of thing that you see them paying a lot of attention to in terms of how to develop codes to deal with? That's
exactly right. And when I say seeing them, that is something that I'm fortunate enough to be part of. That is the question you just raised. We call that, we've got chronic care management. How do we deal with chronic care management? And some of it's a complete failure on behalf of government. I mean, the fact that an obscure portion of the Social Security Act prevents what's called not real-time voice video. Right now, it's reimbursement is limited to real-time voice video telemedicine, and it's restricted by geography as well as by places that are identified as a physician shortage area. That's the short version. There's a longer acronym, but essentially where there isn't a doctor within a certain radius. So that's great for rural, but what about urban people that might have just as long a trip to get to the doctor because of public transportation or other reasons? So the government, unfortunately, has failed in a lot of ways to keep up with speed. We are working really hard to try to remove or alter those kinds of restrictions. But the coding element you talk about, that longitudinal data, physicians are actually hungry for it because they see that they need to do more to improve patients. Nothing is more frustrating for a physician than for a patient to keep coming back with the same problem and the physician knowing that it's solvable. It's not like house. You want your patients to get better and you want to be able to see them at the grocery store and feel good about the treatment that you're giving them. So ultimately, we are looking at how do we develop better coding systems to deal with longitudinal data. And that means accepting data not just from FDA-approved medical devices, but also from this panoply of wearables and others that we're going to see. So you're right on the nose on coding being one of those main characteristics. And we have 3 working groups, as I said: privacy and security, effectiveness, and the third is reimbursement. And that's all about how do we do coding, how do we make it legitimate, and how do we make sure that it's effective in the way that those codes are used.
We have time for one more question here. I'm going to bring it over to Lou, because Lou, you did have some issues with the back end, bringing it back from the actual patient experience, the physician experience, to that actionable information that we were talking about earlier. You had a question from Morgan about how we actually get that data.
Yeah, so I think that was the interesting part, is like we have all these data points that we're getting from all these devices, even approved or not approved devices, and what kind of backend, what kind of algorithms do you need to do to provide actionable data going forward? Do they need to be improved? Are things that they're there yet already, or what types of things need to happen already?
Well, Lou, I don't think that's an actual softball for Microsoft, but it is in fact a softball for Microsoft. Microsoft's AI team, having had meetings with them and talked to them, Microsoft is actually looking at those exact questions. How do you pull in the data? And it was interesting earlier you talked about on-prem. There's a shift right now in healthcare to move from on-prem to on the cloud, on remote cloud. And Microsoft is one of the major partners with healthcare facilities to try to make that move. So now that you have that data, and once you meet the legal requirements and the privacy concerns about accessing it, how do you put the right algorithm to it to make sense of it? And so Microsoft is absolutely a leader in this space. We've seen IBM taking some pretty big moves forward on it. But your baseline question is, do we have to have good algorithms and good data science to figure out if we're making the right decision? Absolutely. And that's going to be the other part of the challenge. I think the best way to look at it is the way that physicians practice medicine today. Essentially, the physician is a complicated algorithm machine themselves. They're looking at what they learned in med school, what they've read in the journals, the patients that they've seen, the conversations they've had in the hallway at medical conferences, and trying to make a decision. Now, how do we distill that insight, knowledge, and experience into something that doesn't replace the physician, but arms the physician with the information they need to enhance their ability to make that decision quicker? So right now, it's about gathering the data, putting it against some pretty effective algorithms, and looking at how the results match up with experience. I think that the challenge we're going to face right there is on making sure that we meet the privacy and security concerns that hospitals, patients, and the consumer has. And so earlier, there was Curtis mentioned HIPAA. I think what's really important to note is HIPAA, unfortunately, has become the code word for no, because there is such a great concern of data loss. And what we're working right now is how do we describe industry best practices so that we move HIPAA from no to HIPAA to yes and in this way. And I think that's going to be a challenge that we in the industry are going to face for a little time going forward, but hopefully it's solvable.
Well, gentlemen, I'm afraid that we've done it again. We've used up another hour listening to the best dang enterprise podcast in the universe. That's according to 9 out of 10 data center dwelling IT folk with chronic vitamin D deficiencies. I want to thank everyone who makes this show possible, especially to our guest, Mr. Morgan Reed. Again, he's the executive director of the Connected Health Initiative. Morgan, I'm afraid we have to call it. We have run out of time, but is there anything that you'd like to leave our audience with? A little bit of wisdom as they start looking about how maybe they could be involved in the connected health industry?
Absolutely. Get yourself over to actonline.org. Check out our Connected Health Initiative. Volunteer if you have some data to add. And most importantly, figure out what it is that you do in your business and your life that we can do a better job of analyzing. So we have 3 working groups, looking for help, looking for input. And if you're in the business, then this is absolutely a place to be to make those decisions that make your company, frankly, economically viable for the next 10 years or more.
Again, Morgan, thank you very much for joining us on This Week in Enterprise Tech. Fascinating discussion and something that's not going to go away. Like autonomous vehicles, health and connected technology is going to be with us for a very, very long time. Thank you for informing the Dwight Wright. We also want to thank our, the people who really make this show possible. That would be my co-host, starting with Mr. Curtis Franklin. Curtis, I love doing every episode that I get to be with you. It's like having an old friend over for dinner. Could you please tell the folks at home where they can find you, where they can find your work, and what you'll be up to once the sun comes out over on the East Coast?
Padre, I appreciate it. This is certainly one of the highlights of my week, every week. I'm continuing to write and starting to put together all the stuff for a new series of radio shows and podcasts at Light Reading. So if people want to find me, they can go to lightreading.com, look for my smiling face there at on the author shots next to pieces, or just follow me on Twitter, KG4GWA. I always let folks know whenever I've got a new piece up. And there are some new projects coming out. There are some old projects being revived, something I've been doing with our good friend Brian Chi for a long time. Looks like it might be coming to fruition. And just exciting stuff in the tech world. That we're getting into the conference and show season. So I'm going to be reporting from a lot of conferences this spring, starting in a couple of weeks. So plenty of stuff to follow me for. Look forward to hearing from all of our viewers and listeners.
Curtis, thank you again. It is always a pleasure, and we'll see you next time. Are you on next week? I can't remember. I don't control the rotation, so I never know who's going to show up until we start the show.
Good question. I think so, but I'll have to ask our good buddy Chubert. He controls my fate as well.
So yeah, speaking of kickbacks, that's the man you got to pay if you want to be in the rotation. Lou Maresca, he is the other member of our co-host powerhouse. Could you tell the folks where they can find you, especially now that you're in full-on dad mode with the really respectable hair?
Absolutely. Well, you can always find me at LouMM on Twitter, and you can always check out my work at crm.dynamics.com, and also check out my good friend Noah. Sent out. We had him on one of our other shows a while back, and it was Coding 101. He just released Firebun.com. It's about operational behaviors around businesses like bars and nightclubs and so on. So check out that too as well. He just released it today.
Lou, thank you very much. Gentlemen, it is always a privilege and an honor. And it's also an honor to be with you. You share your time with us. We make this show, but if you didn't download it, if you didn't listen each and every single week, we couldn't keep doing it. And for that, we say thank you. And we want to make sure that you get your enterprise fix each and every single week. Just go to our show page at twit.tv/Twiet. That's TWIET. There you will find all of our back episodes as well as, and this is important, a place to subscribe. If you subscribe to our RSS feed, you can get the version of your choice, audio, video, high-definition video, into the device of your choice. It is the best way to support the show and to ensure that you will get all the Twiet you want into the future. Again, twit.tv/Twiet. Also, don't forget that you can follow me on Twitter, twitter.com/PadreSJ. It's the best place to find out what I'm doing, not just here on Twit, but when I get bored and I do things like finding out who's hiding all of the chocolate in the office under really, really nasty candy, or when I start tinkering around in my maker workshop. Again, find me twitter.com/PadreSJ. Follow me, and we'll take you on an internet ride. Also, don't forget all the people here in the studio who make this show possible. There's Kara, our studio engineer. There's Lisa and Leo, who let us continue to do the show. And, of course, my TD, Kevin. Kevin, could you tell the audience what it is that you do here?
I show up and I show off my bed head, which is the new thing, along with Kara's pajamas.
Indeed, indeed. And of course, as has become our tradition, we always give you an opportunity for redemption at the end of the show to see if you were actually paying attention while you were pressing the buttons. And Kevin, your question is going to be very, very simple. What is the acronym and the actual name, as well as the president and the year in which Bill 104-191, 110 Stat 1936 was enacted?
Open Artificial Pancreas System Project #.
Oh, I'm sorry. We're speaking about HIPAA, the Health Insurance Portability and Accountability Act of 1996, enacted by President Bill Clinton. But we'll get you again next week, Kevin. Thank you very much. That was close. You actually did mention something in the health space, so much better than last week. Until next time, I am Father Robert Balacer, the Digital Jesuit, just reminding you that if you want to know what's going on in the enterprise, just keep quiet.